Welcome to Lunch with Tech Leaders, where we have engaging conversations about software development and cloud engineering with industry leaders and subject matter experts. These episodes are created by the Great Lakes Tech Leaders, an online community of technology practitioners. Please come join the conversation by visiting gltl.rbn.ai. Again, that's gltl.rbn.ai. Now strap in, because we're deploying to production in 3, 2, 1.
All right, welcome to the latest episode of Lunch with Tech Leaders. My name is Ray Welker. I'm a cloud solutions engineer with Right Brain Networks. And I'll be your host today, where we talk about the role of tech in climate change. Joining me today is Derek DeYoungie, as well as software and data consultant Tom Kowalski.
Hello.
And last but not least, our business technology consultant, Joe Coleman.
Hey there, folks. Just want to throw it out there that if anyone has any questions while you're listening to the podcast here, go ahead and feel free to send them in the chat, and I'll make sure that they're addressed in the order we receive them. That way we can really dive in on that topic. So thank you so much.
And again, today, the topic of the episode is discussing the role of technology in climate change. We've got a lot to cover today, so grab your lunch and buckle up.
Yeah, I'm excited. This is one day we talked about doing for a while now, and yeah, it's finally come up, and we're glad to have Zaven with us. If you want to go ahead and introduce yourself.
Hey, I'm Zaven. I work on a variety of projects at the interface of ecology, environmental science, and technology since about 2016. That's been my focus, so maybe we'll get into some of those. Really happy to be here.
Happy to have you.
Yeah, great to have you. So I kind of just want to set the stage. Climate change is definitely a hot topic right now. From the outside looking in, we can see all of the essentially the associated results of that, such as rising global temperatures. Just wanted to throw like a statistic in there. Since the late 19th century, on average, the Earth temperature has risen approximately 2.2 degrees Fahrenheit. That's largely due to increase in greenhouse gas emissions like carbon dioxide, methane, and nitrous oxide. And a lot of that, stems from human activities related to agriculture, our consumption when it comes to fossil fuels, and some industrial processes. Primarily, I was interested in doing this as I was looking at AWS and just kind of like an account overview, and I noticed they were tracking my carbon footprint for the services I was using. So a lot of that stems from like energy outputs of the resources that I'm using, and I just thought it was really neat. It's something I like to try to focus on in my life as well. What can I do to reduce my own carbon footprint, and it's definitely something I think tech can help with. Zaven, maybe this would be a good place to start, but kind of what are the areas that we could use tech in to help reduce those carbon emissions? What are some of those main focus areas?
Sure. I mean, it's everything, right? I mean, if you want to go like really big picture, the reason we have climate change is because of technologies in general, not necessarily information technologies, but those are contributing too, right? So all technologies, we like to say it's an everything, all of the above answer. Everything can have a lower carbon footprint, and everything can develop in a way that's more sustainable. Specifically, I think the things that are going to have the biggest direct impact or the biggest direct relationship with the subject of climate change, it's really energy transition and adaptation, right? So we have to get off fossil fuels, and we also have to build systems that are going to be adaptable to the new climate. So that's carbon footprints. If you're looking at anything in information tech, it's just more efficient use of computing resources. Of course, changing transportation to work off electricity rather than fossil fuels. But there's a big list there. And then adaptation-wise, we need to do things like use less water, put the forests back on the planet, create ecosystems that are self-sustaining so we get the benefits that those, you can think of them as natural technologies that those ecosystem services offer us, that have been in place basically until about 100 years ago.
So, I mean, like it sounds as if we have a lot of data shifting us towards these more green processes. What do you feel is the main blocker or the biggest hurdle that we need to overcome before this is widely adopted?
It really depends on which industry and which specific technology. So there's lots of little questions in every particular thing, but you know, one of the big blockers, one of the things that's exciting about energy transition now, right, is that renewable energy is actually cheaper than a lot of fossil fuels now. And we actually have battery technologies that allow us to start to use electric vehicles. So those have been, kind of fundamental science questions that have been lacking there. The next piece of it to adoption is just connecting people to these alternate sources. So let's say energy grid management is kind of what that one comes down to. There's like some great companies out there that are helping, even helping organizations like AWS change their energy mix. That's a big part of it. How do you get enough energy to run the technologies that you need? How do you know how to buy them? How do you bid on those energies and those energy sources and set the right price? So I think that's one of the really critical parts right now. On the other side, let's go to adaptation though. So what if we want to put forests back on the planet? We have a huge deforestation problem. Forests, although they're not necessarily the only solution to sinking carbon out of the atmosphere, they are going to help us. And they did used to cover most of the planet, and they also cool down the temperature. As the temperature rises, they cool down the temperature on the land and also keep water on the landscape and keep water in the atmosphere. So how are we going to put those back? And that's like a huge GIS data challenge, right? Where are the opportunities to put forests back in to do planting? And then how do we do monitoring of those projects so that we know that they're working? Largely, restoration, whether you're doing forests or rivers, it takes years to restore an ecosystem. And I mean decades, right? And so what we see time and time again is projects are started by this sort of like do-gooder mentality. You put some trees in the ground, or you kind of plant something on the banks of a river, and everyone goes away and they go back to work. And 2 or 3 years, it just all kind of dies back, you know? You have to monitor it over long, long periods of time. And so those are some of the technologies that I've been involved in the last few years. Restoration monitoring, where we're taking pictures of trees, we're using satellite imagery to compare change over time, or we put in situ sensors into rivers, so we get these long histories of data, and we can tell both that things like something is happening and we're going back and checking up, but also what worked. We don't always know what works when we do restoration on the landscape. So I think those are two huge areas, but there's probably 200 things I could list.
Yeah, like the first one that you mentioned of getting it in the hands of others, right? That distribution of it, and like Ray brought up with AWS, allowing you to see and choose different options that are better, right? More economically or environmentally friendly. Because a lot, if you're running your own servers and you may not have different power options. But if you're leveraging something like AWS and they give you those choices to, hey, you can use these servers here that are a lot more, economically friendly. That is one way of giving that power to others to make some change, right?
Exactly. It's like on the one hand, there's choice, and then going with that is the feedback loop where you can see what your choices are doing. So you need to be able to track your own impact on these questions. You need to see how what your carbon footprint was, either yourself or your industry or your business, and you need to see how it changed, and then you need goals too, and be able to predict. So, of course, governments do that on the macro scale, but I think we all, one way or another, need to do that on all scales.
Yeah. Do you get the sense that we may need more government oversight when it comes to maybe adopting these green technologies? I know there's like, the Paris climate agreement, right? Like that's kind of a international policy in place to move towards less carbon emissions. Do you feel like there's any need for more of that, and would that benefit?
It's a contentious question because not everyone thinks that the government is the way to get things done, right? But
Right.
I think the best, and I mean, I kind of see all sides of it personally, but the best answer is that the answer is all of the above. We need that, and we need individuals, and we need business leaders. We need everybody to get on board with sustainable living on planet Earth.
Mhm.
It's like the Paris Climate Accords are awesome, but I don't really think that all governments of the earth are really planning to abide by those agreements anyway. They're only going to abide by them to the extent that they're either their electorate or their populace or their businesses, want to.
Right.
It's not really binding, and it's less than we need. Even that wonderful agreement is still less than really needs to happen immediately.
Yeah. So, we mentioned the distribution of, reducing your emissions and bringing that to others. But what can individuals or companies do to help with the restoration side of it, right? I know there's some projects that you worked on, or, maybe some others, if you want to bring those up.
Yeah. That's a good question. I think something that's been a hot topic in recent years and is really problematic, honestly, but carbon credits, right? Companies buying carbon credits to offset their emissions, and those carbon credits can be things like carbon credits generated by reforestation projects. So that's one of the linkages to restoration that's at least been touted as a way for companies to contribute. And it's not always been done right, and it's also could be like, really, those companies need to do energy transition, not buy something to get out of doing it in order to have the right long-term impact. But it still gets people thinking about it. I think
Yeah.
more broadly, every company can be more sustainable, and every company can cultivate a culture that values restored landscapes. So it depends on the company, right? But I mean, if you're into industrial agriculture, if that's the company, that whole industry is not really very engaged with agroecological principles. So there's a lot they could do. If you're talking about a small tech company, it might be more about what the end goal of the products that they're making are, or taking a look at life cycle analysis of those products. Like, what kinds of impacts do the services and materials that the company is using have on the landscape around them? So there's a more like holistic thought process that everyone can engage in, even if you're not doing restoration. Or maybe you get together with your workmates and do a little river restoration on the weekend or something, but you're not doing that as a company. You can still think in a holistic way about the landscape and how you're impacting it.
Okay. Are there ones that you recommend? Like you said, some aren't done the right way. Are there projects out there that you would recommend that are better than others, or
restoration projects
yeah,
that I would specifically recommend? I mean, that's an interesting question. I think there's tons and tons of good ones. I'm sort of like hard pressed to like name just a single project, but
or was it like a directory or anything, or
yeah, I mean, like, here's a great project. So Greenstand, one of the nonprofits that I've worked with, I was VP engineering there for a couple of years. We do big open source cloud stack and mobile app that does reforestation monitoring with mobile apps in a way where the people doing the monitoring, who would be, say, individuals living in abject poverty in certain areas of the world, they get paid per tree dependent on that tree's survival. So there's incentivization to reforest rather than to what's more common is you cut the tree down and you sell it for charcoal. So there's sort of a social driver to reforestation around poverty. So that project aims to resolve that. And then there are many partners who do the actual restoration work in certain areas of the world. So like a really great one, just to throw one out, the Haiti Tree Project, totally awesome reforestation project in Haiti that works in exactly this way. It's sustainable reforestation. You're putting trees back. Haiti's interesting because it was only reforested recently, so there's still an opportunity to put the trees back in before the soil all washes away. It's a lot harder once the soil washes away. But there's tons. I mean, there's like 1,000 cool projects doing reforestation out there.
I do see Adam jumped in. Did you have a question, Adam?
Yeah. Hey, thanks, guys. Thanks for interesting conversation here. I've always been fascinated by technology and how it, the potential it has to solve humanity's problems. So I wanted to see if anyone on the panel had done any research on, carbon capture and storage technologies. I've seen a few articles that, always have kind of like the clickbaity headlines that make it look like they've solved climate change through carbon capture, but then if you read it, it's like, it's not scalable, or you have to spin up a power plant to run this carbon capture solution. So I guess Zaven would probably be my first choice to answer this question, if he has any thoughts on the actual carbon capture technology, and if that is like a piece of the puzzle, or are we chasing a red herring on that? Thanks. I'll leave the stage. Appreciate the response.
Sure. My personal opinion about it is that to really solve this, if we were really going to solve the carbon dioxide problem, it's not just carbon dioxide; it's also methane, right? The reason everything's happening faster right now than people thought it was going to is because no one accounted for the methane. So that's the big thing right now in greenhouse gases. But anyway.
And methane is largely due to agricultural processes right now, like mass cow farming or cattle farming, right?
That's one of them, but it's a bunch of things. There's also, unfortunately, as the Earth warms, there's feedback loops in places like peat bogs and things like that, where as we get warmer, the bog just gives up all of its methane. So
that's neat.
Yeah, exactly. So that's no good. But anyway, if we were gonna really solve this, if we're gonna really get the atmosphere back to a level that we have been used to for many hundreds of years, I think that carbon capture technology will have to be used. There's just too much carbon going into the atmosphere. We're going to have to suck it down. But the danger is that we focus on that now as though that's going to be the solution for, right now or the immediate future. Because one, it's really not ready. Definitely not ready, which I think is what Adam was kind of pointing out as he's looked into it more deeply. And the other problem is that, the amount of carbon dioxide that we emit into the atmosphere every year is basically equivalent to burning a forest the size of Africa every year. It's an enormous amount of carbon dioxide. It's huge. It's not really physically conceivable that we would be able to quickly just suck that up. It's a huge, huge amount. It's a scaling problem, basically. So there's kind of an order of operations. Yes, keep working on the carbon capture technology. We're going to need that. That's definitely going to need that. But we got to stop emitting. It's like we got to stop right now. Just completely get off of fossil fuels. That's got to be the first thing, because the problem just gets worse and worse every year in an exponential fashion.
That's really some awesome insight. And you say it's a scaling issue as well. Is it also that the technology is just so new that it's a very costly process? Does that have anything to do with it?
I think it's hard. It's energy intensive. And I'm not an expert in the specific carbon capture technologies. I've just bumped into them quite a bit over the years. But you need to use energy to take carbon dioxide and turn it into some kind of solid, or you need a very special type of material that can hold it, and then you got to put it somewhere. all of that takes energy. So where are you going to get the energy from, right?
Right.
And okay, solar and wind are getting more and more efficient. We could have enough energy for that eventually, but it's going to be a big energy footprint. So we better plan for how that's going to work out.
Yeah, so I think the education and awareness is where a lot of how can businesses and technology kind of get started, or hopefully we've already been started, but in doing their part, right? So I think that kind of goes back to, Ray, what you were saying about like having metrics, or this kind of came up because you saw AWS providing those metrics about carbon footprint.
Yeah, it was there and in my face, and I was like, wow, this is very interesting.
I think there's probably some of that has to do with like probably something that we have to start reporting on, right? Especially for companies the sizes of Amazon. But it's interesting that more of this data is becoming available to smaller industries, or just mom and pop shops.
I
Yeah,
agree.
start including it, right, in their offerings. Right, we small little SaaS offering that you have. It's ours is a lot less carbon footprint than our competitor, even. Right?
It's an interesting marketing material. Yeah.
I completely agree, Derek. I think from the perspective of tech, the metrics are a crucial step that could be taken proactively. I think that people in tech that care about this issue could advocate for that in any company. I don't think that there's certain things that are going to be hard to know, right? The carbon footprint of like even a refrigerator depends on the power mix that's being supplied to it. So it can be tricky, but there's other things that are easy to know. Like if you are doing Bitcoin mining, you should stop doing that. It has a huge energy footprint. So those things that's just qualitative, and those things can be talked about more. Just being more honest about what about GPUs, any GPU training. That's very, very energy intensive. You really got to take a hard look at that and determine kind of if it's worth it from the environmental perspective.
Yeah, absolutely. To really make any difference, or I like to call it doing science, right? You have to have the measurement. And I think you're right that measuring your carbon footprint is it's tricky. Like it depends on where you get your energy. It depends on who made the product that you're using, that and what went into the those materials and processes. And so I think getting just starting to demand these type of metrics from like the big folks, right, is a good way to get started, right? I think it's really awesome that Amazon's providing that. I'd like to see more companies start to make these measurements available to us.
Something I've always kind of wondered, and I'm all for, move away from fossil fuels. I think that is, thing we should do tomorrow, today, more importantly. But like the move to electric vehicles, I always kind of wondered the energy footprint that it takes to develop a battery, and then the process that it takes to recycle that battery after that car reaches its end.
Right.
I wish, manufacturers would maybe put in front of me, because that's always a question mark in my mind.
Life cycle analysis of automobiles is terrible. It's a huge energy footprint to just make the vehicle. It would what the real solution is electric trains.
Right.
And, that's the answer. But those like electric trains, maglev, those technologies and those systems are very, very expensive and take a long time to put in. And this like modular vehicle scenario that we like so much it's just so popular right now that probably the first step is electric vehicles, and maybe that'll help the electric cars, and that'll help the industry get more centered around electric motors. That's the key, right? Everything should be electric motors. Electric motors are very efficient, by the way. I mean, just in terms of energy conversion. Fossil fuel engines lose a huge amount of energy just to entropy and heat. There's a ton of energy that's just lost. It doesn't even move your car. It just warms everything up. Electric motors are not like that.
Yeah, interesting point.
Yeah, that is a very interesting point, and not something I've really considered as much. I mean, I'm not an expert in the field. I'm definitely a consumer, but having those metrics in my face as a consumer, I feel like they would need to make better decisions on my own. I did want to. I think Tom might have touched on this a little bit, but are there any news sources or anything that you essentially follow that would maybe keep the listener up to date with what's happening in terms of new technology being developed that's green and sustainable?
Sounds like there's a need for this.
Yeah, I think so.
There's definitely some newsletters out there. I can't think of any that I'm subscribed to at the moment, but I'm sure they're coming into my inbox as we speak. But I can try to dig that up and maybe post it in the channel.
And what's I was going to say, what is something maybe small that the average person could do to help reduce their carbon footprint in their day-to-day life?
Well, I think I want to ask that by going back to what Derek said about metrics, and then dig one step deeper behind that is just to ask the question. That's really like where we're at. First, just in any context that you're in, ask that question, or ask the question, ask for the metrics, and then look for where you can actually find the feedback that's actionable. You won't be able to do that in all cases, right? In some cases, you don't have the information to make the right choice, but there is information to help you make the right choices out there in all the very specific situations that all of you find yourselves in. So I think that's the most critical thing, is just asking these questions as you go through your life and your day-to-day experience. As far as specific things that you could do now, simple things. Eat less meat. Meat has a big carbon footprint. Drive less. Use your bicycle.
Gotcha.
Don't use hot water in your house during what's called the duck curve period. That's at the end of the day when solar generation becomes less viable as the sun starts to go down and everyone comes home from work and turns on all their appliances at home. Really, that's the time of the day. If you guys aren't familiar with this, the duck curve, that's the time of the day when you really should try to use no energy in your house. It's the highest carbon footprint, but maybe depends on the time of year, right? But it's sort of like 5 to 9 p.m. Everybody uses their house hardcore during that time, and there's no solar available because the sun is down. Later at night, there's also no solar available, but people are asleep. So those are 3 things. Just start doing that. That would be awesome.
Yeah, that's definitely riding my bike more is one thing I used to do a lot, and I would love to do with my current living situation. Makes it a little bit more difficult, but yeah, those are great ways that the average person can go about doing that. We are getting close to our 30-minute mark. I just wanted to take a moment to let anybody hash out any final thoughts that they had.
I got a question for you. What's your thoughts on the fusion breakthrough? Do you see that as something you're excited about, right? For reducing fossil fuels in the future, or do you see issues with it, or is it just still a dream?
I mean, fusion would change everything. I we'll see if they can get it working at production scales, and you also gotta. I actually not really familiar with what life cycle analysis looks like for those technologies. Obviously, it's much better than fission. That's one of the reasons we all are excited about it. But you still have to make these huge things. And I don't really know exactly what goes into that or what happens when they break. How expensive is the maintenance? Is it actually, are we actually close to a truly scalable fusion? We've been here before, probably not, right? And even if we were to transition to it, right now, which would be great, we still have way too much greenhouse gas in our atmosphere. We have to get that. We'd still have to get that all out of our atmosphere. Greenhouse gas emissions now force the climate 10 or 20 years in the future, right? So even if we stopped everything immediately, we'd still have to deal with that. And we can't stop it immediately because it's going to be a transitional period. So it's more about the planning, I think, for once that technology is available.
All right. Well, that is our 30 minutes. I wanted to, thank you, Zaven. It was a very, very informative podcast we had here today. I think you had a lot of great insight into all the questions that we asked. Thanks to the audience for being here as well. And I also wanted to, for next week, we'd love to have you guys join us again. Our Vice President of Engineering here at Right Brain Networks, Derek DeYoungie, is going to be hosting that. And as always, the episode will feature expert guests and interactive conversation, so be sure to tune in.
Thank you so much for having me here, guys. This is awesome.
Thank
Yeah,
you.
thank you.
Thank you.